Hello students, we shall do some problems with the application of electric field. Look at this problem. This is from NCERT. Figure shows three tracks of three charged particles in a uniform electrostatic field. Give sign of charges. Second part is which particle has highest charge to mass ratio, and thirdly angle at which particle deflected. Now you know this is positive, so negative. So you can very well see that first part is very easy. 1, 2 are negative charges. Third is positive. It's very clear. That part is very easy. So it's over. Now second part, coming to second part, we have to find out which has got highest charge to mass ratio by Q by M ratio. It's a constant, specific charge. It's called specific charge. It's a constant by which some scientists discovered the charge of electron. Now, so suppose the charge entering at velocity v0. We have to enter its velocity v0 from outside. Now, suppose this length is L. As soon as it's entered the electric field, it experiences a force, electrostatic force. F is equal to QE and F is equal to Ma. Therefore, A is equal to QE by M. Equating both charge, you may be knowing this formula. Now, this is AY. AX is equal to 0. There is no acceleration along the X direction. So, why we can neglect here G here. Why? We know from last class, we see value of AY is very high. That is, acceleration due to electric field is very high, so we can neglect acceleration due to gravity. So we are not considering gravity here. So what will you get? Y is equal to V0. Y is equal to Uyt plus half Ayt square. So Uy is 0. So entering with the velocity V0, there is no common velocity in the vertical direction. So Uy is equal to 0. So y is equal to half Ayt square, that is half QE by M into T square. The acceleration depends upon mass here, not such. The other acceleration is a constant, does not depend on mass. So then what is L is equal to, this, let me L is equal to V0 into T. Because speed is, this velocity V0 is uniform. So T is equal to L by V0. So we have y is equal to half into QE by M into L square by V square. This equation for y. That is, I'll write separately Q by M into EL square by 2V square. Here you see, given electric field is constant, L is constant, given velocity is constant. So y is proportional to Q by M, which has got maximum charge, Q by M ratio, which has got V is proportional to Q by M. Therefore, third charge has got maximum deflection. Third charge has got maximum Q by M ratio. Therefore, third charge has maximum Q by M ratio. Q by M ratio. Now, next part is, it's clear to you? We'll go to next part. The next part is, what is the angle of deflection of charge? Angle at which charge deflects, we can write the formula. Tan theta is equal to uniform projectile motion Vy by Vx. Every motion charge is in. So velocity Vx is equal to V0 is constant. Horizontal velocity is constant. Vy is equal to Uy plus Ayt. So Vy is equal to Ay into T. Ay we know already, QE by M. We have found it already Ay. So Vy is equal to QE by M into T. T is equal to L by V0. Therefore, Vy is equal to Q by M into L by V0. So you can put that QE by L, QEL by MV0. So tan theta is equal to QEL by MV0 by V0, because Vx is V0. So tan theta is equal to QEL by MV0 square. This is the angle of deflection, that is tan theta. Theta is a tan inverse of QEL divided by MV0 square. Here also it depends upon Q by M ratio. EL V0 is constant. So deflection depends upon charge by ratio. It has got maximum charge by ratio, it has got maximum deflection. So students, look at the problem. A block of mass M having a net positive charge Q is placed on a smooth horizontal table and is connected to a wall through a spring, unstressed spring of spring constant K, and as in the figure. A horizontal electric field E parallel to the spring is switched on. Find the amplitude of resulting SHM of the block. When amplitude is maximum, what will happen? This will be in equilibrium. When amplitude is maximum, the spring mass system is in equilibrium. Because why? Equilibrium. In SHM is the mean position velocity is maximum. In equilibrium. So the spring electric field is this direction, charge is greater than 0, charge is positive charge moves this direction. So spring restoring for spring will be backward direction. So at equilibrium, Kx will be QE. Kx will be QE. Let A be the maximum, A is the amplitude. A is the amplitude. Therefore, K is equal to QE. A is equal to QE by K. QE by K. See, look here, we will do a problem of a regular pentagon, or we have placed 4 charges. Fifth one, no charge is there. 1, 2, 3, 4. Fifth one, no charge is there. We have to find net electric field at the center of the pentagon. Look at the question. 4 particles, each having charge Q, are placed on the 4 vertices of a regular pentagon. Distance of each corner from the center is A. From the electric field at the center of the pentagon. If you apply principle of superposition, it will be a complex problem. Not very complex, it will be still complex. Now, suppose let us place a charge Q at vertex 5, fifth vertex. Now, if you place a charge Q here, then by symmetry, electric field will be 0. Symmetry electric field will be 0. This distance is K by Q square, distance by A. So, electric field due to all charges, electric field plus due to all charges, plus electric field due to, this is electric field due to all charges, all electric field charges at 4 vertices. This electric field due to charge at 5th vertex must be 0. Why? Electric field due to 4 vertices. Electric field due to charge at 5th vertex should be 0, because in a symmetrical figure, electric field center of any figure is 0. That you must know. So what is it? Electric field due to charge at 4 vertices is equal to negative electric field due to this one. negative electric field due to charge at fifth vertex. That is, therefore, its magnitude is equal to the charge 1 coulomb here, kq by a square. Very simple it is. Kq by a square. Thank you, students. Next video, some more problem we'll see, mixed problems, omega, friction, electricity, and various combinations of electric fields and all. Thank you very much.